Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with the Descriptive Econometrics, and that too the coverage on sampling and sampling distributions. In fact, in this unit we have already covered couple of things, starting with measures of locations, measures of dispersions, measures of shape, and we have also connected to Excel spreadsheet by using data analysis package. Then we have covered descriptive statistic for group data, descriptive statistic for categorical data, and also we have discussed measures of association, that too the need of covariance and correlation, and in the last lectures we have discussed the requirements of probability and probability distributions. And in these lectures typically we like to highlight sampling and sampling distribution, because these are the components very much required for engineering econometrics, and that too the use of regression modeling for any kind of any kind of problems related to engineering econometrics. And in this lecture typically we like to highlight how sampling and sampling distributions are so important in the process of solving some of the engineering problems by using engineering econometrics tools. So, in fact, we have already discussed in details the need of the probability and probability distributions. In the same way, we like to highlight sampling and sampling distribution, because these are all very much interconnected, and without having probability distributions, it is very difficult to connect sampling distribution. Again, without knowing sampling distributions, so the concept of probability distribution is also meaningless, because our requirement is to solve some of the engineering problems by using engineering econometrics tools, and these are the basics through which we can use directly and indirectly to work out the solution for some of the engineering problems. So, what we have already discussed in the last couple of lectures, that there is a need of sampling structure, and in fact there are two issues. So, the issue is what is the sample size, and that too corresponding to the populations, and what is the typical sampling distributions corresponding to the probability distributions. So, that means here the game is between sample and population, and most of the cases we like to solve the engineering problems by using some of the sample case only, because it is very difficult to go for population as a kind of representative to analyze the engineering problems. So, what we supposed to do, we have to select a particular samples, or we have to pick up a particular sample to analyze the typical engineering problems. So, what is the requirement here? To understand the need for sampling and the importance of appropriate sampling, and then knowing the difference between population parameter and sample statistics. Again, we are interested to know different types of sampling techniques and their limitations, and understand the structure of various sampling distributions, and then we like to connect with some kind of Excel spreadsheet to handle the problems relating to particular sampling distribution. In the Excel spreadsheet, in fact, we have a kind of structures where we can actually generate a random sampling as per the particular engineering problems requirement. Sometimes we can generate the data, then look for the kind of solutions, and sometimes we like to use the actual data followed by a particular sampling technique to solve some of the engineering problems. So, now what is happening here? So, these are the things we are supposed to highlight: aims of sampling, probability distributions, sampling distributions, and the concept of central limit theorem, and types of sampling. In fact, central limit theorem will give you the clue about the optimality of the sampling structure to work out the solutions for the engineering problems. And in fact, population is the set of all elements like set and subset. So, we have the game between population and samples. So, collection of all samples or sum of all samples we can say that population, and within a particular population basket when we pick up a particular samples, then it is called as a sample specific investigation and sample specific analysis. For instance, if you say that the production of a manufacturing industry as a populations, then a particular industry production structures will take you to the concept called as sampling. So, what will it do? We have to pick up a particular samples or a particular case to analyze the particular problems. So, it is basically the generalization process of sampling. So, that is why we cannot target population directly. So, we have to pick up different samples, then you check the results. On the basis of the sampling results, we can comment about the population parameters, whether it is a perfect or not perfect, whether there is a need of change or need to be a constant. So, these are the things continuous process over the time we have to investigate, and then every time we have to check the particular requirement. So, sometimes the issue of sampling is whether it is a good sampling and random sampling, the size of the sampling. So, there is a typical structures, or there is a specific rules and regulation to optimize these things. If your sample specification or sample selection is not perfect, then the choice of a particular technique or the solution to a particular engineering problems may be not correct. It will give you some kind of bias results. So, that is how we are means we must be very careful about the sampling selection and the process of sampling. So, there are two things very important. So, what is the size of the sample, and on the means what is the basis of collecting these samples. So, these are very important. So, once these two things are taken care of, then data side it is not a kind of problem. So, we have to be very careful how to pick up a good sampling with respect to size of the sampling and the collection of data. For instance, random sampling, non-random sampling. So, within the particular sampling we have a couple of structure. So, we have to be very careful how we have to be means we have to deal with all these issues and the kind of requirements. So, let us see what are the process. And first of all, why samples? Sample is a very good representative to the populations to give some kind of comments. So, it leads to confidentiality, the other typical issues like ethical issues. So, non-interference with population, then large sample could alter the nature of the populations, like opinion surveys, and like that we have a couple of things we have to calculate. Of course, it is not a kind of constant process, it is a dynamic process. So, every time when there is a kind of means when something wrong, we can change the particular structure and then pick up the correct samples, and then we go for the analysis. Means what we can say that it is a dynamic process until unless you get a kind of solutions which is very perfect as per the particular engineering econometrics requirement or engineering problems requirement. So, sample and sampling selection is very important so far as solving any kind of engineering problems. So, here there are methods. So, there are two types of methods typically, probability sampling and non-probability sampling. So, in the case of probability samplings, we have a connection to probability, and in the case of non-probabilistic samplings, so we have no connection to probability. In fact, we have already discussed the issue of probability and probability distribution, and both probability and probability distributions they have role in the case of sampling and sampling distribution. So so we must be very careful about the particular structure. So methods of sampling, particularly in the case of probabilistic, we have random sampling methods. So here you have to randomly pick up a particular samples to investigate a particular engineering problem, and in my knowledge this is the best sampling selection means procedure of selecting samples to analyze some of the engineering problems, because it will give you some kind of unbiased kind of inference. If you don't follow random sampling, then there is a high chance that there is a bias in the systems, but in order to avoid all these obstacles, it is better to pick up random sampling rather than a specific sampling structure. In fact, if it is required, then you can follow that. Otherwise, it is always suggestive to follow random samplings so far as size of the sample is concerned and the process of sampling is concerned. So there is a structure called as a stratified sampling. Here the sample is derived from a particular subgroups of a population, and then there is a cluster sampling, and here sample only on the basis of certain clusters of members of the populations, like city blocks, sectors, etc. And multi-stage sampling, it is a combination of random, systematic, stratified and cluster sampling, and finally if probability involved at each stage, then the distribution sample statistic can be obtained. So that means these are all various sampling procedure. Ultimately whatever procedure you have to follow, so there is a kind of process of a random one, and that too the selection should be completely unbiased. Otherwise the data structures may not be correct, and even if you select a good technique, still the results will not be unbiased. In fact, it is not perfect. So that is how you must be very careful while selecting a samples and the process of sampling. So the thing is very clear here. So if your input selection is very perfect, then the output, that is engineering econometrics output, will be very perfect. If your input process is not correct, then obviously the output process will also defect. So that is why you must be very careful how to choose the particular structures so far as a sample selection is concerned and the size of the sampling is concerned. Of course, we will give you details when you work out the particular problems by using any of the engineering econometrics technique. The aim of sampling is to reduce cost of the research. Of course, if you go for population as your kind of requirement to analyze the problem, so the cost will be definitely very high. So in order to reduce the cost, it is better to take few samples, analyze these samples, and then generalize, and that will give you the kind of inference towards the population. So it is a process of generalizations about a large population. So in some cases analysis may be destructive, so sampling is very much needed. So that means technically, so we means the suggestion is that we should go by a sampling process or sample selections and the kind of analysis, not the population specification. And sometimes it is very difficult for a researcher to gather all sorts of data to solve the particular engineering problems. If that is possible or that can be done, so that is called as population kind of inference. Or else if you cannot, then it is better to take these different samples and then connect to the population. So that means even if you select some some of the samples, let us say basket 1, basket 2, basket 3, depending upon the number of sample points, say let us say 10, 15 or something like 100. then you can analyze these samples individually, and again you can pool these samples and again analyze as per the requirement. So, that means technically you have a sample specific analysis and again the kind of sampling distribution kind of analysis. So, like we have actually a time series data, cross section data, then pool data and panel data. So, here also sampling procedure is also like that. So, we have a different cross sectional. So, that is what the sampling, a kind of or a sample selection, and then when you club it, then it becomes called as population. So, that means technically you are moving actually simple case to little bit means a cross sectional to pool. So, that means small sample to large samples and having different kind of diagnostics or kind of shapes to analyze the problems as per the particular engineering requirement. And this is what actually probability. So, what we have already discussed, it is a kind of chance that a given event means the event will occur, and usually the probability value will be 0 to 1 and the sum of probability exactly equal to 1. So, with this means conditions, we have to you have to select a particular samples and then the sampling distribution. And so, for instance, let us say probability distributions, and here what is the probability distribution of number of girls in a family with the 2 children, right. So, means so there are 2 family, and what is the probability distribution number of girls. So, that means this distribution will be either there is no girls or both the family having girls. So, 2 extremes. So, if both the family having girls, then this starts with GG. So, like here, and again if there is no such happens, then it will have a 0. Otherwise, in one family 1 girls and 1 boy, again the reverse is also true. So, that means there are 4 such possibilities can occur. Obviously, while analyzing this kind of problems or issues, so permutation combinations they play very excellent roles to create a kind of distributions as per the particular engineering requirement. This is how the distribution. So, like and this is how 0 1 1 2. So, then ultimately this is how the distributions, and to make it more interesting, then you can extend this particular process. You can start with it to 3 family, 4 family, 5 family, then the process will moves from simple to complex. So, if you are starting or the minimum requirement or minimum kind of structure is very perfect, then extending the kind of process is not so difficult. So, that means we start with the simple structure, then generalize it, or you can extend it to as per the particular requirement. For instance, if there is a family of 3, then it starts with the one extreme will be G G G 3, then the 0 0 0. So, that means no girls and all girls. So, that means in between one family having 1 girls and other 2 families having no girls, then there are many different instances altogether, and these are the things are here, like what I can say that so these are all possible cases. So, maximum will be 3 girls from 3 family, and minimum will be no girls, that is 0. So, V. So, in between there may be 1 girls out of these 3 family, then and that depends upon which family, again family 1, family 2, family 3. So, obviously, since there are 3 families, so one case will be 3 means 3 such situations. Again there is a high chance that 2 girls out of these 3 families. So, so there are 3 cases against. So, ultimately, so we have 8 different cases, So it depends upon the kind of structures. Ultimately, how many such cases can occur, it depends absolutely in the form of a concept called as 2 to the power n. So so obviously we can have the kind of structure and create a distribution. So this is again, if you plot like this is a 0, and that means this is what the probability, and again in the middle case one girls and 2 girl case, it's more or less same. That's three situations. Then this is also same case. So as a result, in the middles both are same, and the left skewed and right skewed, the kind of probability is also same. And if you add all these probability, then it becomes 1. So again, so how is the structure of 10 family? So that means it will extend like this. So again, so the minimum will be 0, then maximum will be tens, that is one such case. Then in between we have a 1 girl case, 2 girl case, 3 girl case. Likewise we have a various kind of options, starting with here. Say this is actually 0, then 1 girl case, 2 girl case, 3 girl case. So these are all number of possibilities, and then if you will actually plot, then it will generate a particular distributions. In fact, if you look this distribution, it is looking like normal distribution, and it is good for the particular analysis. So likewise you can actually extend this problem, and then if you join midpoints of this particular probability, that is what we technically call as frequency, then you will get a normal distribution curve. So so ultimately when we are in the process of analyzing the problems, we like to have a samples, or size of the samples, and the kind of distribution. It should be a perfect one, and it should be as per the particular requirement. Usually normally distributed sampling or sample is very good one for any kind of analysis. So we try to restructure in such a way the particular process should follow the normal distribution. That's what we call as symmetrical distribution. And if it is possible, you can try. If not possible, then you can compromise, and then you connect with the different other different distributions. But it is very always very good if you the process of sampling or the kind of selection of sampling should follow the normal distributions. But we have but at the same times we have the kind of structure. If it is not normally distributed, then how do you analyze this problem? So that is how we have a different distributions, and in addition to normal distribution, you should know other distributions simultaneously and connect the modeling accordingly as per the particular requirement. So this is another way of looking the particular distributions. Both all are normally distributed, but they are different with respect to shapes. That's what we have already indicated with the help of skewness and kurtosis. And so sometimes I think the red one is a very good ones, and this is a little bit very kind of kind of different kind of shapes altogether. And in fact you must be very careful how you have to deal with such situation. In fact all these cases it follows normal distributions, but which particular shape is perfect depends upon the kind of means depends sample to sample and the kind of size of the sampling. Sampling distribution is the probability distribution for all possible values of the sample statistics. So that means it is actually extending kind of things. So we start with this samples, then the cluster of all samples called as a sampling distributions, then the cluster of all sampling distribution will called as population. This is how we have to extend our understanding and extend our analysis. So that means technically every time you may have a three types of analysis: sample specific, sample distribution specific, and then towards the population kind of requirement. So ultimately touching population is very difficult, but doing the analysis at the sample and sample distribution is very easy, and that is actually means that is the process which you can call as best process of the estimation and inference. So sampling distribution of the sample mean when it is a kind of structure called as random sampling, and if not, it's called as non-random sampling. Sometimes we are connecting with a sample to population, so we have a finite samples and infinite samples, but most of the cases we will deal with a kind of finite sample case to analyze the particular problem. And this is how the is kind of linking between sampling to populations, and in fact when we have a kind of finite population and infinite populations, and that means technically there is a huge connection between sampling distribution to the population. So on the basis of sample statistics or sampling distributions, so we can generalize to the populations. So that is how the structure we have to follow. And then in order to justify the best sampling or the kind of need of the normally distributed structure, so we can connect with the central limit theorem. So the structure of the sample central limit theorems, that's what called as CLT, is that if you increase the sample size indefinitely, then the particular distribution will follow normal distribution. And for the clarity, most of the distribution will converge to normal distributions once you have once you increase the sample size indefinitely till you reach that particular requirement. So central limit theorem will give you such kind of clarity and confirmations whether the particular distribution is normally distributed and what is the kind of requirement, so that the particular distribution will converge to normal distributions. So here again same things, it's a question of population to sampling distribution. So in the case of sample, the parameters are recognized as small n mu, and in the case of population, the parameters are capital N and again mu, and in the case of population, the population variance is called as standard deviation sigma, and in the case of sampling distribution, it's called as sigma x bar, which is nothing but actually sigma by root n. That's what the with respect to population. That means from this formula also it is clear that there is a link between sample to sampling distribution and sampling distribution to the population. So theoretically, if you just add up substantially, and then you will converge towards the populations, and again with the help of sampling distributions you can actually comment about the population parameters. Sometimes some of the cases population parameters are known, and then you analyze the issue, and sometimes in population parameters are not known. So with the help of sampling distribution statistics or sample statistic, you can actually predict the population requirement or population structure. And this is how the kind of process, and means these are all different kind of look how to actually extend a sample size and then check the pattern of the distributions. So if you take a case and increase the samples and then check the shape, then you will find most of the instances increase of sampling will definitely create a path for normal distributions. This is what the cited examples, and so this is the classic examples here. So these are all probability distributions, and this with respect to individual informations, and this is with respect to intervals, but in any case you can create a kind of distributions as per the particular requirement. Okay, so this is randomly generated Excel sheet to analyze a particular problems, and in fact sampling distribution corresponding to probability distributions, we have the kind of binomial, normal, Poisson and uniform. So that means technically here we need actually samples or sampling to analyze the problem, and sometimes we use actually probability distribution to generate the sampling. So if the problem is connected with let us say binomial, so then you use the binomial distribution and then specify the parameters, then it will give you the kind of spreadsheet to analyze the engineering problem. Again, if the problem is connected to Poisson, so you use Poisson statistic. Poisson means you use Poisson parameters, you first fix, and then give the kind of random proxy to generate a kind of spreadsheet to analyze the particular engineering problem. So that means here to create a samples or the kind of sampling, so we have to take care, or we have to connect with a particular probability distributions, because the generation of sampling definitely has a connection with a particular distribution. Since we have a couple of distribution, so definitely the particular problems will be connected to a particular distributions. So there is no such possibility where a particular problem will not connect to any distribution. So every problems will be will be converged or connected to either binomial or normals or Poissons or a kind of uniform distribution. And likewise, there are couple of other distributions, but these are all standard distribution through which you can analyze the engineering problems by using some of the engineering econometrics tools. So if you go to the actually Excel spreadsheet, and these are all actually various commands, and that to work out the particular distribution. So in the last lectures, in fact, we have discussed about the binomial probability structure, normal distribution structure, log normal, beta distributions, uniform distributions. So every distributions you have a population parameters, and then regarding the sampling sample generation, you have to specify the indications, then automatically it will give you a spreadsheet for the kind of empirical estimation process. For instance, if you need to actually generate a binomial distributions, and then the following command can be used. So just you go to the Excel spreadsheet and put equal to signs, and then by default by being for binomial distribution, this command will be coming. So you have to just fill up the trials, then the particular probability, and then randomized figures, then automatically then particular distribution will be created. Similarly, for normal distribution, so this is you heard the command. So random structure, and then mean standard deviation, because mean mu and standard deviation sigma is the population parameters for normal distribution. So this is how the kind of variation will be you can make. For instance, you may create one sample case, two sample case, or multiple sample case. So mean standard deviations will be constant, and then you can change the randomized figures between 2 to 3 or 2 to 5 or something like that. Then on the basis of that, you can have a more kind of spread and a different kind of sampling to analyze the engineering. Similarly, for log normal distributions and beta distribution. So that means technically you have to create a sampling on the basis of different probability distributions. So these are all different kind of examples. For instance, a sampling experiment for evaluating capital budgeting projects, that is mostly corporate finance problems, and one way of evaluating capital budgeting problem is to compute profitability index. That's the equality that is equal to present value divided by initial investment, and then for that how you have to create a kind of because capital budgeting is nothing but give you some kind of prediction structure about the future. So, whether the project is a feasible one or not feasible ones, or if it is a feasible one, at what extent, at up to what point of time. So, all are depends upon the kind of probability and the kind of distribution. So, likewise you can see here. So, this is the case, and for that we have created a kind of normally distributed Excel spreadsheet. So, here we have to specify the kind of parameters mu and standard deviations, that is 12 and 2.5, and that is for present value, and in the case of initial investment we put 3 and 0.8. Then we are giving the randomized figures, and by default we will create actually these are all various experiments, and as a result we have a present value generated spreadsheet, then initial investment spreadsheet, and then finally the kind of profitability index. So, likewise you can actually work for various problems, and if you plot all these things, then this will give you some kind of snapshots about the particular distribution, whether it is normally distributed, so or it is a kind of skewed distributions, whether it is the right skewed or left skewed, and what are the ways again the adjustment can happen, and that means technically the right skewed and left skewed can be materialized, and then finally we have a normally distributed figure to analyze the particular problem. So, these are all various kind of structure about the sampling and sampling distribution, and that to connect with some kind of probability distribution. In reality or in the statistical world or econometric world, the following distributions are very common, and like starting with the Bernoulli distributions, binomial distribution, Poisson, uniform, normal, exponential, and discrete uniform, geometric, then negative binomial, hypergeometric, triangulars, log normal, and beta, and these are all actually Excel commands, and every distribution has a parameters and then the choice of the random variable x. So, you have to fix the parameters value first, and then give the a proxy to for the random variable x. By default it will create a sampling distribution or sample points, and on the basis of that you can actually go for analyzing some of the engineering problems. So, that means technically if you have no actual data, and with the help of a particular distributions, if you know that particular problem is connected to a particular distribution, and with the help of some structure or some kind of feedbacks, so you have to specify the parameters, and then we can generate a sampling, and finally with the help of these samplings you can analyze this particular engineering problem. So, that means technically it is a very easy to do these things, because we have a different kind of scenarios, and your problem can be connected to a particular scenario, and as a result you can have a solutions as per the particular engineering problems requirement. So, likewise different cases, and then you have to check every times depending upon the particular requirement, and ultimately some of the issues are how to fix the sample points and the kind of sampling distribution, then comment about the populations, the particular choice of the distribution like binomial, Poisson, uniform, something like that, and on the basis of that actually you have to be very accurate or very perfect about the sampling, and that too for the particular engineering problems requirement. So, that means technically, so these are all actually different goodness fit to streamline the process of sampling and sampling distribution, and these are all different modes again. So, ultimately, so in this particular unit we have gone through various items that means these items are very essential for further processing or advanced requirement of using any kind of engineering econometrics, and that to solve the engineering problems. Of course, any hardcore modeling or any complex engineering problem solutions, we need to have a descriptive econometrics, starting with the kind of measures of locations, then dispersions, shape, and the kind of sampling distribution, probability distribution, the kind of associations. So all these things are there, and in between some of the inferential statistics or inferential econometrics you have to connect, and then that to means the requirements of the validity of a particular models for analyzing any kind of engineering problems. In fact, we have no separate lectures for inferential econometrics. We will directly go to the predictive kind of structures, where we use frequently the regression modeling. And in the regression modeling, two things are very essential in the process of analyzing any kind of engineering problems, and that too by dealing with some of the engineering econometrics technique. So the first requirement is the descriptive statistic, the association statistics, and then the kind of inferential econometrics. So descriptive econometrics, inferential econometrics are the basics for any kind of advanced engineering econometrics. Until unless you go through all these descriptive structure and inferential structure, you are not in a position to analyze any particular engineering problems and to validate the results and come with a kind of solutions as per the particular requirement. With this we will stop here, and in the next lectures we will start with regression modeling. Thank you very much. Have a nice day.